Right then, everybody, it's 12 o'clock. I'd like to welcome you to the Pipeline Industry Skills webinar. Today we've got a talk given by Atmos International on the leak and theft detection system. They did come runner-up last year in the technology awards with this product, and that's why we thought we'd invite them to come along to give you a talk. If I could ask everybody to go on to mute, save any questions till the end, and over to you, Harry. Thank you very much.
Thank you very much, Sean. Hello everyone, I'm Harry Smith. I work with Atmos International and I'm a sales and research engineer, and as Sean introduced, today I'm going to be talking about our new and latest hardware, which is a non-intrusive leak and theft detection system. So just before I go into what our non-intrusive leak detection technology is, I just want to give you a brief introduction into Atmos International. So Atmos International is primarily a pipeline technology company, and we primarily concentrate on leak and theft detection and simulation technology. We've been around since 1995, and since then we've implemented hundreds of pipelines in over 60 countries. Our solutions are for every industry, so our leak and theft detection systems work in the oil industry, gas, chemical, water, mining, aviation. We can do theft detection, and we can also work in multi-phase as well. We're a global company. We have offices here in Manchester. We have 2 in the US, 1 in Costa Rica, 1 in China, and as you can see from this map, we have agents dotted all around the world, which means we can supply leak detection systems into any country that needs our technology. So I just thought I'd show you the suite of software and hardware that we provide. So we have a range of leak detection software and hardware as theft detection, simulation, and we also do other operation management systems such as pig tracking, batch tracking. Today, I'm primarily going to be talking about our leak and theft detection systems and the improvements we made on that. So what are the challenges that we're currently facing in the leak and theft detection market? Well, over the last few years, there's been quite a change in policies, and quite a lot of countries now want to protect their pipelines, one, from theft and leaks, but more importantly, they want to reduce the environmental impact if a pipeline leaked. Now, the problem we're starting to face now is a lot of these pipelines were constructed many years ago, and when they were being constructed, leak detection was never on the agenda. So we're now dealing with pipelines that often have lack of communication, lack of power, lack of instrumentation, and they might even lack cabinet space or housing for the equipment we need to provide a reliable leak detection. On our other pipelines, we're having some issues where we need to improve our leak detection performance. So how do we improve our sensitivity, our response time, and our leak location accuracy? So what is the solution? Well, Atmos has developed what we call the Atmos Eclipse unit. And this provides all the essential instrumentation we need to provide a reliable leak and theft detection system in one package. And the biggest advantage that this Eclipse unit has is it provides non-intrusive flow, pressure and temperature all in an ATEX Zone 1 box that can simply just be attached to the outside of the pipeline. So as its key benefits, it can work on painted lines. It works on diameters as small as 4 inch to as large as 30 inch. The reason we can't go in bigger than 30 inch is because of the spacing of the ultrasonic flow meter heads. They're limited by how far we can move them within the body of the Eclipse unit. So as I said, it can combine non-intrusive flow, pressure and temperature. It has all the onboard processing and communication we require. So that means we can communicate on a fiber optic system. We can work on 4G VPNs, and we can work with line of sight radio link. If you look at the 2 images, the top right, I just wanted to demonstrate. So this is how we would attach it to the pipeline, which I'm showing you one with the rain cover, the weather cover, and one without, just to demonstrate. So this metal part is the non-intrusive ring, and the non-intrusive pressure is a strain gauge. So what we're measuring is we're measuring the pipeline as it expands and contracts during flowing or static conditions. Right and left of that is the ultrasonic heads, and that also allows us to read speed of sound for density changes, and it also allows us to read surface temperature as well. So this is a bit more of a breakdown of what this Atmos Eclipse unit provides. So as I said, it provides a complete ATEX Zone 1 housing that allows us to collect and analyze the leak detection data or theft detection data we need to provide a reliable leak detection system. It has 4.5 hours of flash memory, so if communication fails, the unit will store it locally, and once that communication is re-established, push that data back. As I said, it works with a range of communication options from TCP/IP, line of sight radio, and GSM 4G, 3G, and we can also communicate with data over Modbus. The main advantage it has is it's a complete non-intrusive solution, so it provides non-intrusive pressure, flow, temperature and speed of sound, which is what we use when we're installed on multi-product pipelines, where we have to be able to know when the product's changing in the line. The other advantage this Eclipse unit has is it has available slots inside a device to install additional instrumentation. Let's say your pipeline already has an existing flow meter or existing pressure transmitter, we can connect those instruments into that device via 4 to 20 milliamp. It can handle high consequence areas and extreme temperatures from -20 to +60 Celsius. Because we're now moving into theft detection, we've now got this Eclipse unit certified IP68. This means we can now bury the device to a depth of 2 meters to prevent tampering from the thieves. It has all the suites of power options from 110 volt AC to 30 volt AC to solar power options to 24 volt DC. And more importantly, this Eclipse unit that has to be installed in pairs, so you always have, let's say, one at your inlet and one at your outlet. It will work with all our leak detection software, from our negative pressure wave system to our flow balance to our very long-standing LDS software, Atmos Pipe. So I thought I'd just give you a little bit of a development timeline of how we came to have the Atmos Eclipse. So in 2010, before then, we were primarily a software-based company, and we would purely use the instrumentation that was available on that pipeline. What we realized is that we needed to offer better sensitivity, better leak location accuracy, and better response time. So we started to develop our own hardware. So in 2010, we developed what we call the Atmos AWAS unit. And this is a very small and compact RTU that allowed us to sample pressure sensor data, flow data, temperature data at a very high acquisition rate, 60 samples a second. This allowed us to dramatically improve our system performance. Move forward 6 years, and we had our first attempt at our non-intrusive pressure, which is what we call the Atmos Halo. Again, it has the same technology that's in the Eclipse, and it was a strain gauge to measure as the pipeline contracts and expands. So it doesn't give you an accurate reading of the pressure, but what it does pick up is it shows you the changes on your pipeline. And then the main thing we're interested in as a leak detection company is seeing those changes caused by a leak or a theft. As we move forward 2 years, we take the benefits of that non-intrusive pressure and we combine it with non-intrusive ultrasonic flow meters, temperature sensors. We take the high acquisition rate that the AWAS unit provide, we build that into the Eclipse. We build in the array of communication options we have. We make sure it works with solar power. We make sure it works with our LDS systems. And most recently, we've now allowed it to be a buriable device. So where do we recommend these Eclipse units to be installed? In the next few slides, you're going to see different types of configuration options that we would recommend. So the first one, you can use these Eclipse units to reduce slack regions or vapor pockets on your pipeline. So you can store these devices either side of a slack pocket, which means those areas have less impact on the leak detection system. We can install them on river crossings. So for example, we've just received an inquiry in Africa where they wanted to provide leak detection on a pipeline that runs less than about 900 meters across a river. And the reason they need leak detection here is it's got a high population of hippos, and in the past these hippos have damaged the pipeline, and they need to know if there's damage caused by the pipeline if a leak has occurred. We can work on long distance pipelines. So if you have major levels of network or long distance sections, we can install these eclipses in pre-existing valve pits buried underground, or we can attach them on above ground pipeline, as this diagram shows. And we can build them in urban areas as well. Now, what I wanted to move on to next is to demonstrate to you the projects that we have currently ongoing that are using this non-intrusive Eclipse technology. Now, the first pipeline is a large network in the United Kingdom. This is using our non-intrusive Eclipse units. So this is around 2,200 kilometers of multi-product and jet fuel pipelines. And the customer working with required a complete turnkey LDS system. So over 7 phases, we'll be installing 78 Eclipse units across the entire network to provide leak detection system. Each Eclipse unit is transmitting its data via a 4G secure VPN back to servers that Atmos manage. And any leak alarms or theft alarms are then outputted back to a web GUI that the customer can interact with. The blue circle is the first phase, so we've just completed 12 units installed on that phase, and we're about to commence the second and third phase, as highlighted in the red circle, and that's going to be another 20 to 30 units. I just wanted to give you an example of some of the installation we've done during this first phase. So we've installed 2 Eclipse units in the valve pit. We've installed an Eclipse unit just as the pipeline comes out the ground. Just to give you a demonstration of all the different locations we can install these on. And these devices can be installed on the cathodic protection side because the unit's completely isolated, so it won't cause issues with rust. Unfortunately, we can't install it where you have survey wrap. That would have to come off, but as I said at the start of the presentation, it can work on painted lines. Again, more demonstrations of different units in different locations. Now, what I wanted to move on now is to demonstrate the data that these non-intrusive units are receiving and compare them against an intrusive analog pressure transmitter to demonstrate the type of changes that a non-intrusive unit can pick up. So if we start with this top left screenshot, the pink trace represents non-intrusive pressure data and the blue trace represents intrusive pressure data. Both these sensors are in the same location. What you're seeing in the second window, as demonstrated by the red dotted circle, is a small change in pressure of around 0.3 bar. And both the non-intrusive pressure sensor and the intrusive sensor is seeing that change. This is really positive for a leak detection system because it's these small changes of pressure that we want to pick up, because that means we can see very small leaks or thefts occurring. If we move to the bottom right screen, the non-intrusive in this scenario is in black and the intrusive is in red. Again, let's look at the red dotted circle. This small increase in pressure here is about 0.1 bar of change. Again, both sensors are picking up this change, which means we can see small changes caused by operations or maybe the presence of a leak, or maybe it's a valve closing because of a theft event. Here I'm demonstrating the flow data that we're receiving. So if we just concentrate on the red circle, this is showing raw flow being received by 2 Eclipse units. The pink in this case is flow in and the blue is flow out of a section of around about 50 kilometers. And as you can see, as the operations change, whether or not they decrease the flow or increase the flow, the sensors are picking that up. And you can cross-check that with the pressure as well. So this is the non-intrusive pressure, and it's also adjusting with speed of sound. So if there's a change in the density because of a new product being introduced, the system can detect that change. Moving forward, as well as the UK, we've had an Eclipse units installed in Belgium for leak detection. Again, this is a multi-product pipeline, around about 120 kilometers long, and the section that this Eclipse unit is being used on is about a 40-kilometer section. What I wanted to demonstrate with this pipeline system is real leaks that have been done on this. So the customer, once the device was installed, picked a location that we didn't know where it was, and they performed a set of different leak sizes. So if we concentrate on the top left again, and the non-intrusive in these screenshots is black, and there's an intrusive pressure sensor around 30 kilometers away in pink. So this first leak is around about 1% of the nominal flow, and this pipeline flows around 300 meters cubed an hour. And as you can see by the red dotted circle, when the leak opens, there is a clear pressure drop that both the sensors detect. And because we can detect that pressure change, we know where our devices are installed. We use GPS to timestamp each piece of data, and we know the speed of sound in the product. We can accurately provide a leak location. Move forward to the next screenshot. This was a much smaller leak, so this was around 0.6% of the nominal flow. Again, as the leak occurs, there's a small change in pressure. Our system detects that change and again provides an accurate leak location. So this is demonstrating that even though it's not touching the product, the non-intrusive part of the Eclipse unit can detect very small changes in pressure caused by the presence of a leak. And the final example I wanted to talk to you about is a number of Eclipse units, 4 in total, are going to be installed on a butane line in Scotland. So the reason I mentioned this one's a slightly more challenging product in terms of the pipeline is always maintained around -8, -9. And more importantly, at one of the locations, they had no available communication. So when we are providing line of sight radio link to transmit data back from these units to their control room. Just to show you a bird's eye view. So this red circle here is where we'll install 2 Eclipse units. We'll install line of sight radio antennas here, and we'll be transmitting the data back to antennas installed on the roof here. And here's just to show you the example of the pipelines we'll be using. So all this undergrowth has been cut back, and the pipelines are under insulation. That insulation will be removed. The Eclipse will be installed on the painted pipeline, and the insulation will be wrapped back over. The installation work is planned to commence sometime this month, and the system should be fully operational in December. So what I've been able to demonstrate to you here is that the Eclipse units have the ability to work on large networks where you have thousands of kilometers of pipeline, and we can provide a full turnkey solution for different communication options, different power options. I've demonstrated that the device, even though it's not physically touching the product and it's only measuring the changes in pressure, it can detect very small changes caused by leaks. And finally, we can do slightly more challenging pipelines as the one in Scotland shows. So thank you very much for listening, and I'm more than happy to take any questions.
Hi. Sean here, first of all. Thanks for the talk, Harry. Much appreciated. Just one technical question. What's the maximum distance you can go in between the 2 Eclipse units?
That would be regarding it's quite diameter specific. So if the smaller diameter, the shorter the distance, but generally we would recommend distances of around 50 to 60 kilometers between them. The ideal spacing, if you could do it, would be 30 kilometers.
And if you had that sort of accuracy, what sort of accuracy could you get on pinpointing a leak to a nearest meter? Or
we would usually, you've obviously got 2 scenarios in a pipeline. So you have running conditions and when the pipeline's pressurized but static. So during running conditions, would generally be plus or minus 150 meters. If we have the sensor spaced every 50 kilometers, in static it would be less than 100.
Okay, thank you. Any other questions from the floor?
Hi, Matt McKenna from Severn Trent Water. I probably missed this from the presentation, but what sort of technology are you actually using? Is it an accelerometer or something like that, or what you're actually detecting from the pipe?
So, well, obviously we have, as I said, we've got ultrasonic heads for the flow. So, and we use those ultrasonics to provide a speed of sound for density correction. But for the non-intrusive pressure, we're just using it's like strain gauge technology. So all it's measuring is as the product flows through the pipeline or is pressurized and static, it just measures changes in the pipeline wall. So it's not actually giving you an idea of an accurate pressure reading as in an intrusive pressure sensor would, but it's just measuring changes. For a leak detection system, that's all we're really interested in. We're wanting to detect these changes that are caused by operational activities or the presence of a leak or theft event.
And so one last question from me.
Yeah, go ahead.
And what materials do you work on? What materials do you work best on?
Well,
pipe.
What materials are your pipelines in? We can work with PVC, steel, plastic. We can work with an array of product types, pipeline types. Sorry.
Thank you very much.
Any other questions? Okay, I'll draw the meeting to a close. Just on the final page there, I've got adverts for the next 2 meetings coming up. We've got McDonald coming up next month, talking about their interesting method they did for replacing a scour pipe for a reservoir wall. And then the month after, just after Christmas, we've got leak tight double block and bleed, which is basically a double line stop. I think we've all seen line stops before. Doing a double one at the same time was quite interesting, the way Stats Group did that. There is a YouTube page now from the Pipeline Industries Guild, link at the bottom, and we'll also put that on the Pipeline Industries Guild webpage so you can find any of the previous talks, and we'll hopefully get this talk on there in the next week. Thanks for your time. Bye-bye.
Sure. Can I just have one more statement? If anyone has any follow-up questions or anything like that, my address is harry.smith@atmosi.com, and my mobile number's there as well. And if you want to gain any information at all, it's all on our website. You can download the data sheets or anything like that. So thank you again for listening.